Hash partitioning is like assigning each record a slot based on a secret code or hash code. Modulo function is a very popular method of hashing. If you have a hash code of 123 and we have 10 nodes, the modulo operation would be 123 mod 10, which equals 3. This means the data would be assigned to node 3. Hash partitioning this way helps balance data distribution. But note, the modulo function is itself guided by number of nodes. So, rehashing can be a significant issue. When the number of nodes changes, rehashing results in full redistribution of data, which can be time-consuming and resource-intensive. Now let's explore range partitioning. Range partitioning divides data into ranges based on attributes like date or numerical value. Each range is then assigned to a different node. It's intuitive and easier to manage, but it can lead to skewed load if the data is not evenly distributed across the ranges. One plus point is when node is added or removed in the cluster, range partition do not lead to significant redistribution of data. However, a node removal can potentially cause heavier load in neighbor partitions. So in continually changing systems, the cons of hash partitioning is redistribution, and cons of range partitioning is skewed load. Both can be handled gracefully by introducing virtual nodes or vNodes. Instead of mapping data directly to a fixed number of physical nodes, we can map to a fixed number of virtual nodes. Each physical node in turn is assigned multiple virtual nodes according to their capacity. If a physical node is removed, its virtual nodes can be reassigned to other physical nodes. This solves the redistribution challenge of rehashing since number of vNodes is constant. Similarly, in case of range partitioning, it mitigates the problem of skewed loads of neighbors during node removal because vNodes can be mapped to any physical nodes. Let's extend this concept to flick through consistent hashing. Consistent hashing uses a hash function to place both data and nodes on an abstract circular space or ring. Let's say the hash ring has definite number of segments. Each data object's hash belongs to a specific segment on the ring. Nodes are also mapped to specific segments on the hash ring. Now when nodes are removed, then the data is assigned to the nearest server on the clockwise direction, but this causes hotspots in the nearest nodes. To mitigate this, we actually use virtual nodes instead of physical server. With constant number of virtual nodes, each has defined positions on the hash ring. So when a physical server goes down, all its virtual nodes across the ring needs to be reassigned. The position of a vNode has no relation with the physical server. Moreover, mapping a vNode to physical server changes frequently. Due to these, the chances of all neighboring vNodes belonging to the same physical server are very low. Thus, the probability of overloading a single physical server is low and uniform distribution is achievable. This is a very clever technique. No wonder it's so popular. Smart nerd! Happy coding!